Okay, so in this problem, what we want to do is find the area under a standard normal curve to the right of the z-value of 1.68. So let's draw our standard normal curve. It looks like this. It's got a hump in the middle. It's got tails like that. Down here on the horizontal axis, these are z-values, that this is a standard normal curve. In the middle here is going to be a z-value of 0, so I'll put 0 there. Then this value 1.68 is going to be over here to the right somewhere, because we got positive z-values over on the right and negative z-values over here on the left. So this is going to be 1.68 over here somewhere. And now this time the area that we want is to the right of that z-value and underneath the curve. So if I shade that in, it looks like that tail right there. So I want the area that's consists of this right-hand tail over here that's to the right of 1.68, z equal 1.68. Now we have a little bit of a problem in that our standard normal table only gives us the areas from the left-hand side of the curve up to a given z-value. So I can't directly look up this area to the right of 1.68 in the table. I have to be a little bit tricky about it. But what I can do is subtract a couple of areas and come up with that. What I do know is the entire area under the curve is equal to 1. If I write the area that we're after, the area of this right-hand tail over here is the entire area underneath the curve, but then subtract off this left-hand tail here that comes up to 1.68. So if I take the entire area, which is 1, and then subtract off this area that's to the left of 1.68, then that should leave me with the area that I want over here to the right. Now I know I can find the area from the left-hand side of the curve up to 1.68 by doing a table lookup. So I'm going to write 1 minus table lookup, and then the z-value we need to use for that is 1.68. So what I got here is I have the area of this right tail over here, and I got that by saying that the area under the entire curve is 1. That's this portion right here, and then subtracting off the area that I don't want, which is the area from the left tail here up to 1.68. Okay, now if I go to the table and look up this second area over here, this guy, I need to find 1.68 in the table, so I go to z-value 1.6 and then go over to the column that says 0.08, and I find out that this is 0.9535. And then if I subtract those two values, so 1 minus 0.9535, I'm left with 0.0465. So this tail over here doesn't represent very much of the area, actually. It's only about 5% of the area. So if I change this to a percent, if I move the decimal over 2, it's about 4.65% of the area. And then if we round this off to the nearest percent, it would be about 5% of the area. So this tail over here represents about 5% of the data this time.